Welcome to Lesson 12. This lesson is titled Writing and Graphing Systems of Linear Equations. In today's lesson, we're going to recall what it means to solve a system of linear equations and how to do it by graphing. First learning target today, explain what we mean by the solution to a system of linear equations and explain how the solution is represented graphically. Number 2, explain what we mean when we refer to two equations as a system of equations. And number 3, use tables and graphs to solve systems of equations. Our warm-up is 12.1, titled Math Talk, a Possible Mix. Diego bought some raisins and walnuts to make trail mix. Raisins cost $4 a pound and walnuts cost $8 a pound. Diego spent $15 on both ingredients. Decide if each pair of values could be a combination of raisins and walnuts that Diego bought. So, if we look at this, I have $4 a pound for raisins. So we could say 4R. And we have $8 a pound for walnuts. So we could say 8W. And Diego spent $15 total. Now we can substitute these values in and see if it gets us a true statement. So if we have 4 pounds of raisins, that's 4 times 4, plus 2 pounds of walnuts, that's 8 times 2. Does that equal 15? Well, 4 times 4 is 16. 8 times 2 is 16. And 16 plus 16 is 32. And that does not equal 15. So that cannot be a possible solution. Next, we have 1 pound of raisins. So that's 4 times 1. And 1.5 pounds of walnuts. So that's 8 times 1.5. 4 times 1 is 4. 8 times 1.5 equals 12. And 4 plus 12 equals 16. That does not equal 15, so that cannot be a possible solution. Next, we have 4 times 2.25 pounds of raisins plus 8 times 0.75. 4 times 2.25 is 9. 8 times 0.75 is 6. And 9 plus 6 equals 15, which does equal 15, so that could be a possible solution. And finally, 4 times 3.5 plus 8 times 1. 4 times 3.5 equals 14. 8 times 1 equals 8. And 14 plus 8 equals 22, which does not equal 15, so that cannot be a possible combination. So the third combination is the only one that could possibly be a solution to this problem. Our first activity is 12.2, titled Trail Mix. Here is a situation you saw earlier. Diego bought some raisins and walnuts to make trail mix. Raisins cost $4 a pound and walnuts cost $8 a pound. Diego spent $15 on both ingredients. Write an equation to represent this constraint. Let X be the pounds of raisins and Y be the pounds of walnuts. So this is the equation we used on the previous page. So that is 4X plus 8Y equals 15. Now they want us to use graphing technology to graph the equation. So we can use the Desmos calculator. We have 4X plus 8Y equals 15. So this red line is our equation. And when we say we graph a line, we're saying every single point on this line is a possible set of solution points. Complete the table with the amount of one ingredient Diego could have bought given the other. So first we want 0 pounds of raisins, and raisins is our X. So if we go to 0, we can see that our answer is 1.875. So in here, we can say 1.875. Next, what if there was 0.25 pounds of raisins? So now we're going to zoom in until we can find 0.25. Now that we have 0.25, we're going to go up until we hit the line. And we can see that at X equals 0.25, Y equals 1.75. Now we want to know when Y equals 1.375. So we want to go this way until we start getting near 1.375. Now I want to zoom in. Now we look at 1.375 on the y-axis. We go over until we hit the line, and we can see that the value here on the x-axis is 1. So now we can fill out that block on the table. We would have to have 1 pound of raisins. Next, they're giving us y is 1.25. So we want to go until y is 1.25. Here's 1.25 on the y-axis. Go over until you hit the line right here. Go down to your x-axis. And you can see that your x value is also 1.25. So our answer here would be 1.25. Now we want to go until our x value is 1.75. So now we are looking for an x value of 1.75. You might want to zoom out a little bit to make this go a little quicker. Here is 1.75. I can see that if I have 1.75 on the x-axis, I go up until I hit the line. Then from there, I go left to see what the y value is, and I can see that the y value is 1. So that would be my answer right here. And finally, what if we say our x value is 3? Scroll out to make this a little bit easier to move around. Now I want to look for an x value of 3. I want to go up until I hit the line, and I want to zoom in to make this easier to read. X value of 3, go up until I hit the line, go left until I find a y value, and my y value is 0.375. So that's what I'll write in the table. So you can see that in using a graphing technology such as the Desmos calculator online, you can plug in your equation, it'll graph the line for you, and then you can just zoom in, zoom out, move around until you find the value for the variable that you're given, and use that to find the variable that you need to find. That way you don't actually have to go through all the steps mathematically. Says here is a new piece of information. Diego bought a total of 2 pounds of raisins and walnuts combined. Write an equation to represent this new constraint. So now, if my raisins are x and my almonds are y, the pounds must equal 2. Use graphing technology to graph the equation. So we're going to go back to the Desmos calculator. And now in number 2, we're going to type our new equation. X plus y equals 2. And then we're going to zoom out. And now in blue, this represents the pounds of almonds and raisins bought, whereas in red, we were representing the price of the raisins and the price of the almonds. So this is what we would call a system of equations. So now we're going to complete the table, but this time we're going to use the blue line, not the red line. So raisins is x, so we want to go to 0 on the x and see what our value is on the y. And we can see right here, if my x is 0, my y on the blue line is 2. Now, what if my x value is 0.25? So I'm going to scroll in until I can get 0.25. And now I'm going to scroll up until I hit the blue line. So at 0.25 on the x-axis, I go up until I hit the blue line. I go left until I find my y value, which is 1.75. Now they're going to give us a y value of 1.375. So I want to go here on the y-axis until I can find 1.375, and I'm going to start scrolling in 1.375, scroll over until I find the blue line. I hit it right here. I go down to see what my x value is, and it's 0.625. Next, we have a y value of 1.25. So I'm going to zoom out until I find 1.25. Should be right around in here. Scroll in a little bit. I can see a y value of 1.25. I go over until I hit the blue line. Go down and see what my x value is, and it's 0.75. Next, they're giving us the x value of 1.75. So we want to know where x is 1.75. Right here. I see my x value of 1.75. I go up until I hit the blue line. I go left to find my y value, and it's 0.25. And finally, they tell me I have an x value of 3. If I have an x value of 3, I go down until I hit the blue line, and I have a y value of -1. So again, we can fill out this table of values using a graphing technology such as Desmos calculator. And remember that this equation was our blue line. So number 3 says Diego spent $15 and bought exactly 2 pounds of raisins. How many pounds of each did he buy? So the only way we can do this is that the lines are going to have to cross. This is the only time we're going to have the same value. And that happens when there are 0.25 pounds of almonds and 1.75 pounds, or I'm sorry, 0.25 pounds of raisins and 1.75 pounds of almonds. So that is right here, or walnuts. I'm sorry, not almonds. So this right here is the only time these are going to match. Because if I try to look at 0, my walnuts are 1.875, but when I look at 0 here, it's 2. At 0.25, it's 175, and it's 175. They match. Here, when I'm looking at price, 1 is 1.375, but when I'm looking at pounds, it's not 1 anymore, it's 0.625. The next row is 0.75 when I'm talking about pounds, and 1.25 when I'm talking about price. In the fifth row, when I'm talking about price, this is 1. But when I'm talking about pounds, it's 0.25. And on my last row, when I'm talking about pounds, we put -1. But when we were talking about price, we talked at 0.375. So when we say that it satisfies both the price and the amount of pounds total that we bought, we can either look at where our lines cross, because red means every single point makes the first equation true, and every single point on the blue line makes the second equation true. So the only point that makes them both true is where the lines cross. Or if we look at our table, we can say the only value where the rows are the same is the one where they meet. Okay? Can you find other combinations of raisins and walnuts besides this that meet both the cost and weight constraints? No, because these lines only cross one time. Also, it is the only row in both tables that matches. Every other row is different between the two tables. How many possible combinations of raisins and walnuts meet both constraints? Only one, because we have two straight lines. And two straight lines can either cross one time, they can never cross, so they run parallel, or they can meet exactly because it's one line on top of the other. In this case, what we had was two lines that crossed one time, so that one combination is the only combination that meets both. How do we write a system of equations? And what is a solution to the system below? We would write them with this bracket, where we would put the first equation and then the second equation, and this is how we would write the system of equations. What is a solution to the system? The only solution to the system was that x equals 0.25 and y equals 1.75 pounds. So we would write the solution as a point pair. 0.25 comma 1.75. This is my x value, this is my y value, and that is the only point pair that satisfies both. Our next activity is 12.3, meeting constraints. Here are some situations that each relates to quantities and involves two constraints. For each situation, find the pairs of values that meet both constraints and explain or show your reasoning. A dining hall had a total of 25 tables, some long rectangular tables and some round ones. Long tables can seat 8 people, round tables can seat 6 people. On a busy evening, all 190 seats at the tables are occupied. How many long tables, X, and how many round tables, Y, are there? So this is a system of equations. First, we know the number of tables is 25. Long tables are X, and round tables are Y. So if we add the number of each type of table, we're going to get a total of 25 tables. Next, we know the long tables can seat 8 people, so we would say 8 people per long table. plus round tables can seat 6 people, so 6 people per round table, and that is going to give us a total of 190 people. And this would be our system of equations. Now what we can do is go to our Desmos calculator. We can clear out the previous ones. We'll zoom back out. And now we will start to enter these. We said x plus y equal 25 tables. So the green line represents our tables. Now we can enter the other equation. We said 8x plus 6y equals 190. So my green line represents the number of tables. My blue line represents the number of people. And we said that a solution to a system of equations is the point at which these lines cross. And we can see right here, this happens when our x value is 20 and our y value is 5. So we have x equals 20 long tables and y equals 5 round tables. So we need to understand how to create the equations, how to type those equations into a graphing calculator, and then how to find that where those lines cross is the solution to our system of equations. Next, a family bought a total of 16 adult and child tickets. A is the child ticket, or adult tickets, and C is the child tickets. So this would say A plus C equals 16 tickets. Adult tickets are $10.50 each. So that is 10.50A. Child tickets are $7.50 each. So that's 7.50C. And that equals a total of $141. We put our bracket here. That is our system. Now we can go in and type these into our equation. So A plus C, or x plus y, equals 16. If we zoom out, the black line represents the total tickets. Then we said $10.50 per adult ticket plus $7.50 per child ticket would equal a total of $141. So the black line represents the total number of tickets, and the red line represents the total cost. So the solution is where these two lines cross, and they cross at 7, 9. So we would write our solution as 7, 9, which means 7 adult tickets and 9 child tickets. So again, make sure you know how to write the equations from the information that is given to you. The first one represents tickets. The second one represents cost. Then plug those into your graphing calculator. Then look for the point where those two lines cross. That gives you your point pair that answers both equations. Then translate that point pair back into what it represents in context. Number 3, at a poster shop, Han paid $16.80 for 2 large posters and 3 small posters. Kieran paid $14.15 for 1 large poster and 4 small posters of his favorite TV shows. Posters of the same size have the same price. Find the price of a larger poster, L, and the price of a smaller poster, S. So first we need an equation that represents Han. Han had 2 larger posters plus 3 smaller posters and paid $16.80. Kieran had 1 larger poster and 4 smaller posters and paid $14.15. We put our bracket. This represents a system of equations. Now we can type those into our Desmos calculator. So we have 2x plus 3y equals 16.8. Then we had x plus 4y equals 14.15. The solution is where these two lines cross, which we can see is at 4.95 and 2.3. So that tells us 4.95, 2.3 means large posters were $4.95 each, and small posters were $2.30 each. So again, you need to understand how to write the equation. You need to understand how to type those into your Desmos calculators. You need to understand how to find the point where they cross, because that's the only point that makes them both true. And then you need to understand how to turn those point pairs into what it represents in context. What do you notice about the strategies used by your classmates? Why might it be helpful to write a pair of equations to solve these problems? And are there situations in which it might not be helpful to write equations? Well, it's helpful to write the equations because if we can put those into a graphing calculator, the solution that solves both of them is the point where they cross. Are there situations where it might not be helpful to write equations? Probably not, unless you can know right away just by looking at it what the answer is. But even if they don't cross and there is no solution, it'll at least let you see that they are parallel lines that never cross. Our lesson synthesis. How would you explain a system of equations to a classmate who is absent today? What would you say if they asked, what does it mean to solve the system of equations? So a system of equations would be two different equations that represent different items within the same situation, such as one equation representing the pounds of raisins and walnuts that were bought, while the other equation is representing the cost of the raisins and walnuts that are bought. So it's representing the same situation. They're both representing the raisins and walnuts, but one is representing the physical quantity of them, and the other is representing the cost of them. When we mean the solution or solving the system of equations, we're looking for the combination point pair that makes both of those true. And when we find that, we find the one combination in these instances where they're both true. So now I know that if they spent $15 and they bought a total of 2 pounds, I now know the one point that makes both of those statements true. And that is the solution to my system of equations. Here are graphs that represent this system. Which point or points are solutions to the equation x plus y equals 4? So in this case, the black line, every single point on the black line, such as E and C, are solutions to the first equation. Which solutions are solutions to 5x plus 10y equals 25? That is represented by the blue line. So that could be points such as D and C. Which are solutions to the system? Well, C is the only one that is a solution to the system because it's the only point that makes the first equation and line in black and the second equation, which is the blue line. C is the only point that makes them both true. So it is the solution to the system. What are the same and what are different about solving a single linear equation in two variables, such as x plus y equals 4, and solving a system of equations, such as this one given? What is the same is that when we are representing these, we represent these as straight lines. We're saying every single point on that line makes that one equation true. What's different is that when we're talking about a system of equations, we want to know any point that makes them both true at the same time. So when we looked before, every point on the black line made the top equation true. Every point on the blue line made the bottom equation true. But only point C made both of them true at the same time. Our cool down is on Kidam. It's 12.4, fabric sale. At a fabric store, fabrics are sold by the yard. A dressmaker spent $36.35 on 4.25 yards of silk and cotton fabrics for a dress. Silk is $16.90 per yard, and cotton is $4 per yard. Here is a system of equations that represent the constraints in the situation. So the top equation represents the yards of silk and the yards of cotton equaling the total amount of yards. The bottom equation represents the cost of silk plus the cost of cotton equaling the total cost. What does the solution to the system represent? Well, this will represent the yards of silk and cotton that add to 4.25 yards and cost $36.35. It has to be the right amount of each, and it has to be the right total cost of each. Number 2, find the solution to the system of equations. What we can do is plug these into our Desmos calculator. So first we have x plus y equals 4.25 yards. That is our purple line. Then we have $16.90 per yard of silk plus $4 per yard of cotton equals $36.35. So the solution is the point at which these cross. And they cross at 1.5 to 0.75. That is 1.5 yards of silk and 2.75 yards of cotton. That is the solution to the system of equations. So we have 2 glossary terms for this lesson. Solution to a system of equations, a coordinate pair that makes both equations in the system true. On the graph shown of the equations in a system, the solution is the point where the graphs intersect. And equivalent equations. Equations that have the exact same solutions are equivalent equations. So if you feel comfortable stating the lesson goals, then consider this lesson a success. If you still have questions, then please bring those questions to class and have me clarify them for you before our next test. Thank you for your time.